Hi everyone, I'm Nico. So we're going to talk about Runtime Optimizer 0.2.2. We've covered in previous sessions, there's videos about it on like the basics of Runtime Optimizer, what the tool is trying to do, how it is the tool that we recommend people use for any sort of like GPU optimization and trick issue that you might find. The idea behind it is to lower the barrier to entry for profiling like an expert. Normally you'd need someone that is an expert in RenderDoc to do any sort of like GPU optimization, and you just can't narrow down what the issues are. Runtime Optimizer is very tightly coupled with your Quest headset to give you like insights on what's going on. It has two parts. One of them gives you deep analysis and like suggestions of what you can do with your game to improve it. Where are your bottlenecks? Are you GPU bound? And if you're GPU bound, where in the GPU are you bound? If you reduce your textures, is that going to improve your game? All those good insights are one part of the deep analysis that we offer. And then there's another thing that actually is shown in this picture here, which is the what if analysis, which gives you an idea. This is actually a capture that we did in our last session, and it gives you an idea of, game objects and what their GPU cost exactly is. So, what is the cost of any game object? It gives you a millisecond breakdown of it. So we're going to do a little bit of an overview of what's new with Runtime Optimizer 0.2.2. And feel free, if this is completely new to you and you're interested in knowing more about what you can gain from this Runtime Optimizer tool, highly recommend viewing these like videos that I believe, Michelle, you've already shared with the group or are accessible to the group. These are just previous recordings that we had. But there's also a lot of documentation online and videos from other, developers that have made videos about this. So highly recommend you check it out. Then we're going to go through the preview of our new Perfetto, LLM, and just going to talk a little bit about AI and how we see it, being a very interesting tool, particularly for performance optimization. It is, I think, a good helping hand in terms of like, hey, these are complicated problems. These are, complex subjects, all these names of like, I don't know, shader, caching, texture, misses, all these things are just potentially complicated things that need some context. LLMs can be a great partner there. And we are in the process of releasing a tool that, helps you out with, integrating LLMs through an MCP into your game development flow and, helping you optimize your game further. The Runtime Optimizer is for Unity exclusively. Everything else that we're going to go over, all the LLM stuff, that is engine agnostic, and you can apply that to anything. And there's already a Horizon OS MCP, all these things are OS agnostic. You can use it for Unreal Engine, you can use it for Godot, whatever it is. So this is the quick update in our last update of the Runtime Optimizer. It's mainly a performance it's mainly, reliability, connectivity improvement, improvement in this version, but there's also two cool features that I wanted to highlight. One of them is this hierarchy view of all your game objects that are in your frustum. So here, I don't know if you can see my mouse, but you can see the available game objects. You can see how they're hierarchically organized, and you can select the ones that you're interested in profiling and getting the exact GPU cost of each one. So the way that game Runtime Optimizer works, it freezes everything in your frustum and runs experiments at runtime, doing A/B tests, disabling, enabling things, and like freezing everything and getting the delta of both things. And then this is just an interesting, fun way to view things. There's also a new button that allows you to batch a game object. So previously you could only run things at a game object level. Now with 0.2.2, you can batch them and run everything underneath dog001, right? And that runs as a unit, right? So we're going to disable and enable and do this A/B experiment for everything. Those are the main improvements, a lot of connectivity things. So next up, we're going to talk about a little bit about our Perfetto LLM and how that can be applied to your game development loop. Performance optimization is complicated. There's a lot of nuances, as we talked about. And this is normally what the loop looks like. You normally start with a profiling configuration. You decide what to enable in your Perfetto capture configuration, if people are familiar with that. And, maybe I don't know how many people are familiar with what Perfetto is. Maybe we start from there. Perfetto is this tool that allows you to capture, a very comprehensive picture of everything that's happening in your OS, and in your game. And it can show you a picture of like, hey, what functions are being called, how much time is spent, what your threads are doing, et cetera, et cetera. So it's a lot of information, a big breakdown, and what information gets included in the final report is up to the profiling configuration. So you have a profiling configuration, then you create a performance capture. Normally, all of this is done in the Meta Quest Developer Hub, and then someone would interpret these details, run some analysis, create a hypothesis, make some code changes, and iterate on this. Like, okay, it seems like we're GPU bound. Can I add a few more tags? Can I change something in my code? Am I no longer GPU bound, et cetera, et cetera. Now, in the performance optimization MCP that we're creating, so an MCP essentially, if anyone's not aware of what an MCP is, it essentially offers a set of deterministic tools to an LLM, right? LLMs can be pretty random, and there's a lot of reasons why you would want to have deterministic tools. And by that, I mean tools that, hey, if you need to make an API call, if you need to, and you know where to find something, the LLM, instead of trying to figure out how to craft this API call, it knows that it can call the specific tool that makes an API call, and it's going to always work. So having tools is a great resource for your LLM because it prevents it from, going in side tangents that are potentially not going to resolve. And also it reduces the number of tokens used. In most cases, depends. It can reduce the number of tokens used to come to a result. And eventually, the less amount of tokens, potentially the better your conversation is going to be, the better your interaction is going to be too. So great. What we're doing with our V1 of our performance optimization MCP is we're adding a lot of VR specific context. What are, similar to what we have in Runtime Optimizer, right? And we're encoding some of the, what are VR best practices. We discovered that, hey, LLMs are fantastic at creating SQL queries too. So we're offering a suite of, hey, hard-coded SQL queries that the LLM can run, that we know, like, hey, if you want to figure out what a thread is doing at this moment, you can run this SQL query, and you can run these SQL queries on the Perfetto output, but it also can create its own. So it is really good at digging in deeply into what is happening. And lastly, comparing traces. So out of this loop that we're talking about, of the performance optimization loop that I mentioned before, we're looking at having the LLM be your aid in the analysis and hypothesis sections of this loop. So that's what the LLM is going to be doing. And next up, I'm going to show a little bit of a demo. So this is a little bit more tangible of what you can do with an LLM. And, hey, these tools are coming soon, right? But also, these are things that you can start using kind of like ASAP, with this framing of hey, can I potentially get some of the output of my, command that gets metrics out and, put it into an LLM, and what sort of insights can I get from it by giving it some of the VR context that I have, or context of my game and everything. So these are things like our MCP is going to help you in this process, but this is something you can start applying ASAP.
Yeah, so North Star, some of you might know, this is a sample that we published. So this video at the beginning, we just starting with, taking a Perfetto trace. So the UI you're seeing here is, hopefully by now you guys are familiar with it. And, through MQDH, you can take a Perfetto trace. So if you don't know what Perfetto is, it captures basically all kind of signals from the headsets, including the operating system, graphics side. It captures almost everything about what your headset's doing at the moment. Once it captures it, it's a very rich data sets. However, reading the Perfetto is another art. So again, this is something that AI can greatly help. It's able to equip with the right context, is able to go in to dig out the information. So here we can see the UI. There is actually a cursor, whatever AI tool, your choice is almost similar, kind of the same thing. But what Cursor does or Cloud Code is that you add your code as part of the context. So once you run this, what the LM will give to you is a frame breakdown. You kind of can see this kind of similar information in the Unity profiler as well. However, this just kind of even more give you more very fast, right? Very concrete breakdown of your frame time, where it goes, which function goes. Again, LM only can give you as much information as you give to them, meaning that adding profile markers, and enabling other debug information in your code is important. LM will read all of them and use them to contribute to this result. Yeah, so here you can see that it will detect, we put in a whole bunch of guidelines, what might be important, what might be slow. It will detecting function that calls many, many, many times in a frame, for example, very long functions, things like that. It's good at detecting, for example, frame drops. Sometimes you may be making a call to the OS, you don't know how long it might take. It will detect that and tell you, hey, this actually just an OS call that takes a long time that you're dropping frame. So LLM is very good detecting anomalies in the sequence of frames. With GPU data, it's also able to tell you that in sort of like English form that what your GPU are doing. Are you fragment shader or pick vertex shader, meaning that are you drawing a lot of things or you're using complex shaders that, alters the cost of things. I also will tell you, there's kind of what the pipeline stalls there might be. Anyhow, you might not need to necessarily directly know this, but this is just the LM will able to give you the context, and it will also kind of try to suggest what's the best fix. All right, so come here. If you have all your code as the context feeding to the LM, you can literally ask like, hey, how can I remove the cost of certain, in here is the live probe, right? So it will actually go in your code base, digging around, find out, hey, this is probably the LiPro, right? This universal render pipeline has some keywords and things associated with LiPro. It will read the code, interpolate, and say like, hey, what if, just give suggestion where, what if you remove that piece of code? What would it do? Um, so here we simply just copy and paste, right? Like, okay, sure, I'll try your suggestion. You build it, you run it again, you take another trace. Then you can ask LM to say, hey, I want to compare, right? What's the difference between before and after? So this iteration obviously in the video is very fast, but in reality you are compiling the code again and such. So here it's also you can take the information of saying, hey, is there any setting in Unity editor I can play around, right? Sometimes MSAA 422 it's an improvement, but might not be necessary for your game, or shadow map resolution, for example. So all of this LM can suggest, you can ask the question, right? Like, hey, what can I do with just like tuning some settings in Unity to improve frame rate based on your performance data? It will take that and tell you, hey, this is something they want to change about it. For example, and it's extremely important because you want to change the settings with what's happening in your game, right? If your shadow map only takes less than 1 millisecond, and it doesn't make sense for them to suggest oh, you need to optimize your shader, shadow a lot. But if your shadow are taking like 10 milliseconds, of course, it will tell you, reduce the shadow mask size. So you need that context. You need the performance context for the LM to give you the right information. And then that's what the LM is best at. It will read those information, digest it, and tell you, hey, this is the things you could do, and help you optimize your game.
Nice. Great. So what is VR context? What is the VR context that we're interested in? Yeah, there's particularly we find it, yes, the LLM can look at your Perfetto traces without having this VR context and give you some insights, and it's primarily going to be somewhat like quantitative and not necessarily understanding a little bit of the nuances of VR, but it's still useful. Even if you use it right now, you can you can I encourage people to plug it in and see what happens, right? And I think this getting comfortable in and using LLMs while debugging is really powerful. I think I've been surprised while doing it. So yeah, but in our particular MCP, what we'll be offering is this VR context that's going to give it information about like, hey, OpenXR markers, the way that you do frames and divide frames in VR is a little bit different than what you would expect in a normal like Android application or something like that. We use OpenXR, and these markers and context about these markers is important. We also share a little bit of like what are best practices to the LLM, what are the best practices in terms of like an optimization flow. And what are good targets to aim for. And there's a lot of engine specific knowledge, a lot of hardware specific knowledge. Hey, a Quest 3 and a Quest 2 might be slightly different of like what might be a good number of draw calls, what might be a good number for binning or whatever it is, right? GPU time. These things might be different, might be hardware specific. So that's some of the context that we're sharing. Still encourage people to use it even without the MCP, and just experiment with it. And as soon as this comes out, you can also integrate our MCP to your flow, and hopefully that helps. Then we thought about something else a little bit. This is a video that it's potentially not the clearest, but it is an experiment of what happens when you mix the Perfetto MCP that we're talking about with Runtime Optimizer, and create this kind of like virtuous cycle of, hey, you're improving something at runtime and getting details at runtime or disabling things at runtime with the Runtime Optimizer, and you have an AI kind of like backing it all up and like being agentic in terms of like making these changes, right? Well, okay. Yeah, so here we're seeing the same. This is actually the immersive debugger. If people haven't used it, this is one of the tools that is offered in Unity. It has a few things, a few ways of like interacting with, essentially editor functionality inside of your headset, like Unity editor functionality inside of your headset, which is very interesting. And now we're seeing essentially the terminal with all of the VR the LLM back and forth inside of the immersive debugger. So we're seeing the breakdown that we saw previously about, hey, the player loop is looking like this, and this is a breakdown of times, and we can ask it to take a performance capture. That's what Runtime Optimizer does. And right now, what I would recommend for people to include as much context as possible is, hey, if you're using Runtime Optimizer, make one of those deep captures. It has a lot of like very cool data in like Perfetto configurations, and upload that to your MCP, and that's gonna give it a lot of information about the Perfetto, this GPU information. It's gonna give you a lot of information about everything, and you can just have a follow-up back and forth conversation about your performance capture. So here I'm asking it to take a performance capture. It takes a performance capture, and it's analyzing it for performance bottlenecks, and it can give you information about, hey, it's terrain, this prefab is very expensive, and you can just ask it to fix it. There are ways of like I believe Unity, there's been announcements of Unity MCPs that are coming and things like that, and there's other tools you can use, just plain vanilla cloud code or something like that to apply these changes, and then you can measure them afterwards and do an A/B test. I added the little like highlighted text that makes it easier to read the conversation, because this is a lot of text and hard to view in the video, but that's the summary of what's happening. Great. So it finds what the issue is. It removes it simplifies the mono behavior, removes the costly terrain, and it does an A/B test, and it realizes that, hey, this is actually an improvement. Great. So just then that is just a little bit to seed an idea of like, hey, once you are connecting a lot of these different flows, what is possible is really cool, and you can like potentially iterate during runtime. And yeah, that is, I think, our potential North Star. Um, Great. So yeah, so some lessons about, hey, LLMs and performance optimization that we've talked about so far. If you create captures you only will get back whatever you feed into the LLM, right? So the more context you put in, the better. This means, hey, use Runtime Optimizer and the deep traces that you're creating. Upload those. There's a way of downloading them, and you can upload those to your LLM. You can also, and there's also a JSON file that is created that also can be uploaded there. It's just a little bit of a summary. But if you're not using Runtime Optimizer and you're in you're using Unreal or something like that, you can use MQDH and GPU tracing, enable GPU tracing, enable A traces, enable more information, add markers. That is key. We talked about this last time about how to enable profiling markers and how that's a best practice across, while you're developing. You're adding, some interesting math is going on that is being applied, add profiling markers there. And then once you're using Perfetto and creating a Perfetto capture, you'll be able to deterministically know what the cost is of that, right? So it's not going to be bundled in your main player loop, and you're not going to know what is contributing a lot to that cost. If you add markers, it adds more detail, and the LLM will be able to give you an answer, and it will not hallucinate. A lot of people are afraid of that. The more information you give it, the less it's going to hallucinate. Great. And then we have tokens it's very important a little bit to keep track of your tokens. I found that useful in my development, particularly if you're running low, your answers might become worse. So using something like an MCP to reduce that number of tokens, or being careful about where we are in our conversation, maybe condensing or compacting. There's certain functions like MCP functions that come with different agents that allow you to compact the context of your LLM and then potentially give you more answers. So like that is something that I highly recommend. And use the LLMs everywhere. Use them with OVR GPU profiler. You have a lot of information about anything, draw calls, render stage traces, things like that. Just general GPU metrics. That is, this is a terminal tool that you can just copy paste that easily formatted output and put it into an LLM, and you can also like understand trends and things like that. Perfetto and Unity Profiler, or any other profiler you're using, the output, I think it's really interesting to put it inside of an LLM, if that's the lesson here. Great. So yeah, this covers what we wanted to talk about. I hope that was useful. Have a good one, everyone.